Welcome everyone to a very special program today. Harvey Leonard, Chief Meteorologist, Channel 5, Emeritus, is in the house. A warm welcome to Worcester Academy's environmental science students and their teachers. Thank you to Amy Mateer for mentioning Harvey Leonard was recently at another senior center, and she thought all of us would enjoy meeting Harvey and hearing him speak. Thank you, Amy. Today's program is sponsored from donations sent to the Worcester Senior Center in memory of Worcester Senior Center participants Chet and Anna Babinski. We thank their families and friends for their generosity. Other sponsors include Wells Healthcare and an anonymous donor who purchased today's flowers. Thank you, Jim Crozier, for organizing First Helping Harvey today and also organizing the sun-themed music that we have heard as we were all having coffee. Thank you, Jim Crozier. Please also thank the volunteers, Pat, George, Gwen, Linda, Esperanza, Cruz, and Steve Duke for making these tables look absolutely beautiful with our weather-themed centerpieces. Please take time to enjoy the watercolor art on everyone's tables. Elio Sonsini, Professor of Fine and Contemporary Art, who has volunteered at the Worcester Senior Center for the past 12 years, along with his class, created these beautiful and themed sun pieces in honor of Harvey Leonard's visit today. Please do not remove the art from the tables or the centerpieces because they want to take them home. Elio's watercolor class was chosen for an exhibit at UMass Chan at Lake Ave campus called UMass Community Art. His show will be available as well as all of the watercolor students for viewing through April in the UMass Chan lobby. The talented Jim Priscilla will entertain us during lunch. And now I would like to introduce Betty Daly, our dedicated Worcester Senior Center volunteer, who will introduce our distinguished speaker.
Thank you, Suki. Harvey Leonard is WCVB Channel 5's Chief Meteorologist Emeritus. After a 50-year career in meteorology, with more than 45 of those years forecasting weather in New England and 20 of those at WCVB, Harvey retired from the helm of the Storm Team 5 in May 2022 and transitioned to his emeritus role. In this position, Harvey continues to serve the community with important information as a periodic contributor to Storm Team 5 coverage and engage in community speaking appearances. Widely regarded as the Dean of Boston Meteorologists, Harvey has received numerous awards throughout his luminous career. He was selected for induction into the prestigious 2021 Gold Circle presented by the National Academy of Television Arts and Sciences, Boston and New England chapter, honoring 50 years of outstanding contributions to the industry. In 2019, Harvey was named Broadcaster of the Year by the Massachusetts Broadcasters Association, an award presented annually to an industry leader in radio and television who displays an outstanding commitment to their community while showing an unwavering dedication to the evolution of broadcasting. He was also inducted into the 2018 Massachusetts Broadcasters Hall of Fame, an honor bestowed upon individuals for their outstanding achievements and unparalleled contribution to the broadcasting industry in Massachusetts. At the 2016 Boston New England Emmys, Harvey was honored as a prestigious Governor's Award for Lifetime Achievement. In retirement, Harvey is involved in numerous local organizations, including the Huntington Disease Society of America, the Walk to End Alzheimer's event as co-master of ceremonies, and he has served as the master of ceremonies for the Boston Prostate Cancer Walk and his work at the Boston Medical Center. Over the years, Harvey has visited and spoken to hundreds of schools and adult groups. He has been a mentor to numerous aspiring meteorologists, and today well over a dozen of his protégés serve as on-air meteorologists in markets across the country. We are honored to welcome Harvey Leonard, Chief Meteorologist Emeritus, WCVB Channel 5, who appeared in our living rooms daily for over 50 years. Let's give a Worcester Senior Southerner welcome to Harvey Leonard.
Thank you so much. Thank you.
You're welcome. Do you need this? They talk to you.
Thank you, Betty. What a marvelous introduction. Thank you, Betty, for that. I also want to thank Suki, who has been in touch with me numerous times ahead of my actual appearance here. And I want to thank Jim for helping get us set up here. We're actually using my computer, which has a cracked screen and cannot display anything on the screen. I'm going to get it fixed, but I couldn't get it fixed in time. So I went, what am I going to do? So I actually went to the Apple store. I live in Natick. And they explained how we could still present even though the screen's not working. So thank you to them. Thank you to Jim. Thank you all. And wow, what a wonderful large gathering. I certainly appreciate all of you coming, no matter what your age is. I also want to thank the students that are here as well, environmental students, because they're the future of America. So as you heard, I had a wonderful career. I consider myself one of the most fortunate people in the history of broadcasting. And one of the privileges I had was actually combining two professions. So what I mean by that is, in terms of my education a long time ago, it's all in meteorology. And I earned a Bachelor of Science degree in meteorology and then a Master's of Science degree in meteorology. And then the broadcasting kind of came in, believe it or not, mostly like on-the-job training, but that would never happen now. But when I was studying meteorology in college, there was no way to take broadcasting classes or anything like that back in the day. This was back in the 60s. So these days, when students are majoring in meteorology, if they really, really, really want to go into broadcast meteorology, they're usually able to take some classes, minor in broadcasting or TV production or something, to give them a feel of television. And in a lot of the schools that offer meteorology as a degree, they usually have a system. It could be like a cable system within the school, and they have a studio, and so the meteorology students actually get a chance to practice and learn how to present on television, if that's the part of the field they're interested in, while they're at college. So meteorology as a degree or as a background, when I went to school, and for those of you in the back are students, that was back in the caveman era, okay? But when I went to school, there were only 7 colleges in the country where you could even study to get a degree in meteorology. Now that's probably at least quadrupled, and meteorology has gotten also into atmospheric science. Environment, of course, is very important. That's what we're going to talk about in a couple of moments. So it's a much, much broader field now. And as you heard, I'm really so happy and fortunate that some of the college students who were majoring in meteorology that I was able to have at the station with internships are indeed working in TV markets all around the country. So, but I've always told them, or any future students who say, I really love weather, I love forecasting, I want to be on television, I would never discourage an interest because I'm a great example of that, okay? There weren't many other people when I was, growing up that had the interest in weather that I did. So I certainly appreciate the fact that if it's something you really want to do, to go for it. But I also explain now that the field has really widened, and environmental science, atmospheric science, our climate, all of that now are very, very important fields, okay? Now, when I go through the presentation today, I'm going to do my best, all right, to keep politics out of the equation, okay? All right, so just so you know, that's not the easiest thing to do when you get into this, because one of the big problems from a meteorologist's point of view, when you're talking about climate change, you are talking about environmental science, okay? And we try to stick to the science. I will also tell you that probably one of the biggest criticisms that I had, especially in the last 10 or 20 years of my career, and I sympathized and empathized with the criticism, it would be, Harvey, why are you not talking about climate change on the air, or talk about it more on the air? It's so important. You have a lot of credibility, and you're not telling everybody what the situation is or what the danger is, okay? So that was a justified criticism. It certainly didn't ignore the topic. But the reason that I did not do more on it is because it is not a topic that you should or can accurately convey in a 10 or 30-second soundbite. You need a forum like this where I can show you things and I can talk and I can expound upon things. You can't do that. And so if you can't do within a weathercast, and if you can't do that within a weathercast, you're probably going to do more harm than good, because you're going to get misunderstood. Plus the fact you realize that it's a topic that gets a lot of people fired up. Some people, in one direction, some people in the other. But again, I'm going to try to stick to the science of this to the best of my ability. So, because time is not unlimited here, and I so appreciate all of you being here, I do want to get into this. I could talk, of course, but you heard it in the introduction about my background. For those of you who are closer to my age, you may realize that I spent 25 years on Channel 7 before I switched over to Channel 5 for 20 more years. And before that, I was on Channel 12 in Providence, Rhode Island for 3 years. And before that, I was working for a private weather service in White Plains, New York at Westchester County Airport, where our job was to brief pilots so that they would know the weather, where they're taking off, en route, and wherever their destination would be. And sometimes it would be international flights. But these are not like JetBlue pilots. These were pilots who were flying for corporations and would be flying the CEOs of corporations to meetings, could be anywhere in the country. That was the main part of the job. But we also did weather reports for several radio stations in that area, which was the New York and Connecticut area. So that's how I started to get the background in broadcasting, but I started out purely as a meteorologist all the way. So that's a little bit about the background. So what about the fact that I'm a meteorologist, so am I an expert on climate science or climate change? No, I actually wouldn't consider myself an expert. Am I somewhat knowledgeable? Yes. Why? Because it is a related field, number one. And number two, because I would attend every year a broadcast meteorology conference somewhere in the country. We had one a year. It was put on by the American Meteorological Society. That's our, when I say our, as meteorologists, our professional organization. And they would put together a conference. And a lot of the television meteorologists would go, and we would learn. We would have presentations from meteorologists involved in research, new forecasting tools, things like that. We also would give some presentations, some of us as on-air meteorologists, of perhaps some interesting things that happened in our local market, and then share it with the TV meteorologists from around the country. Now, I will tell you briefly, and then I'll get into this, two talks that I gave at these conferences, okay? All right. One of them was, I believe, in the year 2000, where I was given a wonderful honor by the American Meteorological Society. It was an Outstanding Service Award for a broadcast meteorologist, a national award. So that was very special. And so I gave a talk that year. And to that point, I was still at Channel 7. I had been there at that point for about 23 years. And in those years, from 1977 to 2000, in this area, Channel 7 was not the most popular station. Channels 4 and 5 were far more popular than Channel 7. So what happens in the TV industry is, if your station is not doing as well in the ratings, not as many people are watching, there's likely to be more changes in the anchor team. Now, I was fortunate that I wasn't changed, but the anchors around me were constantly changing at Channel 7 in that era, from 1977 to 2000. While at WBZ TV and WCVB TV, very stable, very popular anchor teams, well known, a lot of promotion, a lot of community involvement. So it was really a challenge for Channel 7 to strongly compete in the ratings. So based on all of that, here was the title of the talk I gave in 2000 at the Broadcast Meteorology Conference. It was this: How to Survive 18 Different News Directors. That's not the punchline. With a steadily receding hairline. And it was very well received, and that was one report. The other presentation I gave at the conference was, I think, back in 2015. So we just are coming out of the winter season now. 10 years ago, we had an epic snow season, the winter of 2014, 2015, all right? We had record amounts of snow, 4 massive storms within 3 weeks. And as that was happening, I realized, wow, this is really historic. So I wanted to be able to present it. So with the help of one of my college interns at the time, who's now a television meteorologist, we put together a PowerPoint presentation. And I needed to give it a title. So the title I gave was Buried in Boston. Okay? Because that's kind of where we were, all right? Now, so I gave this presentation to a national conference of television meteorologists, and before I could even start, somebody's hand went up. Now, I'm just going to excuse me for 1 second to our students, because you probably won't get this, and it's not your fault. But somebody raised their hand to ask a question, most unusual, before I've even started the presentation. And I said, what's the question? And they said, why is a meteorologist giving a talk about Whitey Bulger? Okay, now I'm sorry, I don't mean to only include part of the group with that joke. But for those of you who are young students, please ask your parents or grandparents if you remember this little thing. But it's anyway. That, of course, I wasn't thinking about that when I gave the title. So that was a talk that I gave. But getting back to this, at these conferences, we also would be able to take short courses so that we could continue our education. And during the course of these conferences, I took 3 over the years, 3 courses, brief courses on climate change, so that I would be more knowledgeable about it. And I will also tell you that at Channel 5, there is a project, and it began shortly before I retired, which was, believe it or not, almost 3 years ago already. Can you believe that? So anyway, it's called Forecasting Our Future. It's not just explaining climate change, which I'll try to do today. It's what's being done about it, or what can we do about it, okay? And so there are occasional reports that mostly the meteorologist, sometimes it could be a member of the news team, will do from time to time. So just before I retired, I got to do one report, all right? And I want to briefly tell you about that report. But first, in order to tell you about that report, just to let you know, yes, I've been in New England for half a century, blessed and fortunate, but I cannot say I'm a native New Englander because I'm from New York. But by the way, just out of curiosity, is anybody else in this room from New York? Oh, we do have a few. Okay. So I grew up in the Bronx, all right? And I know what some of you are thinking. Oh boy, must be a Yankee fan, right? No, not a Yankee fan, never a Yankee fan. My father was a big sports fan and loved to root for the underdog. So wait till you hear this in the back. When I was growing up in New York as a little boy, there were not in baseball the Los Angeles Dodgers and San Francisco Giants. Both those teams were in New York. It was the New York Giants in the National League and the Brooklyn Dodgers, okay? So when I finally came up to New England in 1974, becoming a Red Sox fan was pretty easy because I was 95% of the way there because I detested the Yankees. Because as a little boy, if you rooted for the Brooklyn Dodgers, you did not like the Yankees. So that's what happened with that. But in any event, I'm sprinkling in a little bit of history. So when I went to college, City College of New York, a commuting college, so I would walk 6 blocks, get on a bus, take the bus up to the Grand Concourse, get on the D train, get off, and then walk about a mile onto the campus of City College of New York, which is in Harlem. So that's what I did. But like anybody else who's ever tried to make a bus or get on a bus, the most frustrating thing is you're walking there, you're just about there, the bus is there, and it pulls away. But let me tell you what was worse than that would be the thick, black exhaust smoke blasting in your face, probably taking years off your life, okay? Anyway, so I have vivid memories of that. So I mentioned I got to do one report on this Forecasting Our Future. And I went up to Beverly, Mass. On the North Shore, where they had just started to introduce electric school buses to take the kids to and from school. So I was going to do a report on that. And I got to ride on one of the buses. And I rode on a lot of buses in my younger years. And first thing I noticed is it was relatively quiet. For a bus, relatively smooth. But then, of course, flashback. Thick black exhaust smoke blasting in my face. So I said, I've got to take a look at the exhaust system. So I ran around to the back of the bus. There is no exhaust system. It's electrical. And I said, wow, just that alone, not having the thick black exhaust smoke blasting in your face, that's progress, okay? So that was the one report that I got to do before I retired on that topic. All right, so with all of that as a background, I do want to go through this. But I want to first let you know, what about the idea of climate? For example, it's important to know the difference between weather and climate before we even get started. Or, why do we even have weather in the first place? Okay? Well, it all has to do with the way our planet Earth, revolves around the sun. It does it in such a way that different parts of our planet are getting different amounts of energy from the sun at the same time. So that sets up temperature differences on the planet. And in physics, this is not complicated. This is one of the simpler rules of physics. Temperature is directly proportionate to pressure. So if you have temperature differences, you're going to have pressure differences. And that's going to introduce wind, which is the movement of air from high pressure to low pressure. So we start with this differential heating around the planet, temperature differences. And of course, the planet's trying to achieve a balance. So the cold air from the northern latitudes tries to move south. The warm air from the southern latitudes tries to move north. And then they often clash. And they clash at a latitude very close to where we are. So even though we're in an overall drier period, it's unusual for us to have long-term droughts because we're just located at a latitude where the battle between the cold and warm is often waged. And when that happens, we develop boundaries or fronts separating the cold and warm. And then little disturbances or waves of low pressure, storms, develop on the fronts, and those are the areas that produce precipitation. So that's how we get weather in the first place, okay? Now, the difference between weather and climate. Well, it's a little cloudyish today, and if I were to give you or anybody that you might watch or listen to or look at an app and find a weather forecast for today, tonight, tomorrow, maybe even out to a week, that's all part of weather. So what's climate? Climate is the average of weather over a much longer period of time. So when we talk about our climate changing, and it appears that it's warming on average, okay, that's what we're talking about. So it means don't ever overreact to one particular weather event. One weather event is not going to prove anything. It's the average of weather over a longer period of time. That's climate. And that's what is changing, and that's what's going up on average. There may be lots of ups and downs, and you'll see that soon. But the point is, on average, it's going up. And one of the best ways I can give you an example of that is there is a great resource in Milton, Mass. It's called the Blue Hill Weather Observatory, okay, 600 feet up. It's actually considered a national landmark, and it has continuous weather records going back to 1885. It's the station with the longest continuous weather records of any station in the country. And I was at a conference recently. I was acting as an MC. We call it the Southern New England Weather Conference, which occurs every year. And it occurs somewhere near Blue Hill Weather Observatory. And someone was presenting and showing the whole weather record during the course of these 140 years, okay? And guess what we find? Lots of ups and downs. But the point is, we are now at Blue Hill 5 degrees warmer on average than 140 years ago. So with all the ups and downs, the average is going up. So that's another thing I want you to understand with climate change. The fact that we appear to be warming does not mean that we will never have a cold winter again, or we will never have a snowy winter again, going shucks, right? But what it means is more likely as we go into the future, a higher percentage of winters will be warmer than average as opposed to lower than average, okay? So that is the idea behind it. And one other example, and I promise we will get to this, which will flow pretty quickly. And that is that 2 years ago on February 4th, 2023, incredibly cold. Boston was 10 below zero. Not Worcester, Boston, all right? It was the coldest temperature in Boston since 1957. And I ran into a few people that happened to recognize me. Hey, Harvey, where's global warming when you really need it, huh? I understand the reaction. It's so bitterly cold. Like, if we're really warming, how can we have the coldest temperature we've ever had since 1957? Good question. Well, the very next day was February 5th of 2023. And it was a Sunday, and I actually traveled down to Norwell on the South Shore to a place called the James Library, where they had asked me to do a presentation on the blizzard of '78, because the next day was going to be the 45-year anniversary of the storm. So I drove down, got down there at 1 o'clock in the afternoon. I mean, the presentation was indoors, not outdoors, of course, but it was 52 degrees there, one day after 10 below zero. That's really unusual, because cold air is heavier than warm air. It's harder to dislodge. So to have a change like that is remarkable. But it also means that cold outbreak was intensely cold, brief, but intensely cold. But here's the thing. I then look back at the month once it ended, February of 2023 in Boston. It averaged between 2 and 3 degrees above normal. So yes, it was bitterly cold, the weather on February 4th, 2023. But the climate for the month of February was actually above average. So that's an example of the difference between weather and climate. Okay, I think that's enough background, okay? And I'd much rather you look at something more interesting than me, so now we'll get into this presentation. By the way, this is for everybody in the room, but especially our students in the back. This presentation, the actual graphics are supplied by an organization called Climate Central. And they have a website, climatecentral.org. So it's climatecentral.org. And, you know, especially those of us who are a little bit older could probably spend the rest of our lives on that website because there's so much information there, okay? So that's one. Even if you went to nasa.gov and went into the climate section, you'd find an immense amount of material. By the way, Climate Central does provide graphics for all the television stations in the country, and any of them can use those if they wish, okay? All right, so let's finally get started. So the idea behind this are the 3 S's. That climate change is relatively simple in terms of what we're talking about, but it is potentially serious, and it's solvable, the 3 S's. Now, I don't mean to be a Debbie Downer, but the solvable is a big challenge. I think we can certainly mitigate and do something about it, but solving it is not easy, all right? For one of the reasons you've heard, of course, which we'll talk more about, carbon dioxide, the greenhouse gas, okay? And that there's more and more carbon dioxide in the atmosphere. And the greenhouse gas will prevent heat from escaping, leading to a warming, okay? That's the idea behind it. But the thing is, why do we consider carbon dioxide such a serious greenhouse gas? Some people have said, isn't methane worse? And I'd say, in some ways, yes, but carbon dioxide, once it's in the atmosphere, unless we find a real way to get it out, it's there for a long time. It has a long shelf life. Methane has a much shorter shelf life. So they're both important and challenging greenhouse gases, but carbon dioxide is considered really the most significant. All right, so the idea is not that complicated. Most of us know the burning of fossil fuels, one of the byproducts, and of course I'm talking about coal, oil, natural gas, one of the byproducts is putting carbon dioxide into the atmosphere. So the more all of this happens, the more carbon dioxide gets up there, okay? And remember I said I'm going to try to prevent being political, because that's not the name of my game at all. I try to stick to, the science. But some people will say, well, why should we as a country be trying to do so much about it? Is it going to make a difference? Even if we go green, even if we do supposedly all the right things, what about the rest of the world? What about China? What about India? Okay? Because to some extent they're having their industrial revolutions now. And that's when all of this started with the burning of fossil fuels and all that. So the idea is, well, you could either be defeatist about it and say, well, there's nothing we can do about it, forget it. Or you can say, well, maybe we can lead the way, and hopefully the rest of the world will follow. Okay, so there's different ways, obviously, to look at that. But it's very interesting because 99% of the atmosphere is made up of nitrogen and oxygen. And these greenhouse gases are so important, yet they're only trace amounts, okay? Water vapor, carbon dioxide, methane, and nitrous oxide are the four most significant greenhouse gases. So the greenhouse effect, the idea is, especially on a sunny day, but even when it's cloudy, some of the sun's rays do get through. Obviously, we get warmed on a sunny day. Temperature goes up. I mean, you could have a wicked strong cold front, so strong that this happens sometimes in the winter. Temperature can be dropping even with the sun out, okay? But in general, if it's clear, we're going to warm with the sun during the day, and then we cool at night because the heat of the day goes back out to space. So that's the idea behind it. The sunlight reaches the Earth. Now, some of it is absorbed, and some of it is reflected back into space, okay? So that's the basic idea with this. All right. So here's the thing, though, all right? When we talk about at night, when a lot of the heat of the day goes back out to space, but the more and more greenhouse gases are in the atmosphere, then some of that heat of the day that tries to radiate back out to space at night is going to get trapped by the greenhouse gases and not leave, not escape. So by that theory, you would think that if we're having a warming on the planet, it would be showing up maybe more at night than during the day. In other words, the nighttime low temperatures are going up on average more so than the daytime high temperatures. And that is exactly what we have found. They're both warming on average, days and nights, but the nights even more so. So that kind of makes sense. Now, believe it or not, there was talk about this as early as the 1800s, all right? So it's not like this was never thought of. But in all honesty, and again, I'm stressing the entire group here, but this is really important because I'm not sure that our students in the back, that would know this yet. Maybe they have, maybe this has happened in their studies. But in 1974, Time magazine, one of its editions on the cover had the following headline: "The Ice Age cometh." That was exactly 50 years ago. And the feeling was, oh, we're going to get colder and colder now. We're going to go into a cold spell. There was some theory about that. And there have been long-term changes that happen over multiple hundreds of years, okay? Because there are other factors, not just greenhouse gases, that affect our climate, of course. But the point was that you can go back and you can look at all different things. There was a little bit of a cooling in the 60s into the early 70s. That's what prompted that headline. But in the last 4 to 5 decades, you're going to see the warming. And not only that, but it looks like it's getting more pronounced over time. So we'll get to that in a moment. So that's it. The burning of fossil fuels puts carbon dioxide in the atmosphere. So by burning coal, oil, and natural gas, we are the ones responsible for that. So humans are actually warming the planet. So here's a look at temperature and carbon dioxide, okay? So there's the amount of carbon dioxide in parts per million in the atmosphere from 1880 up to, this was about 2019. Now, okay, it's going up. It's been going up the whole time, but look at the angle, okay? It's going up more sharply in recent decades, most likely, or certainly an important component of that is carbon dioxide, all right? More and more of it being released into the atmosphere. So what about the temperatures during this time? Let's take a look at that. And you go, well, wait a minute. They're up, they're down, they're up, they're down. Of course. There's the weather patterns. The general circulation of the atmosphere still exists, okay? Different types of patterns can cause different things. It's not like we never had, hurricanes 50 years ago. Like if we have a bad hurricane now that hits Florida, and everybody says, is that climate change? No, because we've always had storms. So we had one, and we had a couple of bad ones hit Florida this past hurricane season. And then a couple of years prior, we had one that hit Fort Myers, Florida, called Ian. And it really, really did a number on Fort Myers. It was very strong, like borderline Category 4, Category 5. And so the feeling was, is that due to climate change? Or you might hear a political person, for political interest, say, oh, climate change caused that hurricane. That's an irresponsible statement. But here's a responsible statement, in my opinion. Hurricane Ian was probably going to form anyway. But because the ocean waters off the west coast of Florida were running 2 to 3 degrees above normal, that gave even more energy and juice for the storm to become even somewhat stronger than it otherwise would have been. So the theory with hurricanes going forward, not necessarily that there'll be more of them, but that a higher percentage of them could be major. And those are the ones that do the largest amounts of damage. Weather extremes in all directions, you know, major hurricanes, extreme drought, fire seasons. There's all sorts of things, but they're all extremes. And extremes are costly. And when you're in the business that I was in, your first responsibility is to protect human life or anything you can do to help that. The second is protection of property. So those are the two things when you get into extreme weather that we're always talking about. Okay, so this is just an example of a couple of cities. Here's Oklahoma City, showing that the temperature, the average temperature has gone up probably about 2 degrees in the last 40 years or so. You might not think that's significant, but it is significant, especially if it continues on out into the future. Now here's a look at Philadelphia, but you will notice on that graph, there's a little dip on the left early on. That was a little bit of cooling in the 60s to early 70s that prompted that Time magazine headline at that time. But even though there's some ups and downs, you can clearly see the general trend last 4 or 5 decades is clearly up. So when I said, you know, simple, serious, solvable in terms of climate change, and I said, well, solvable, you know, mitigate, yes, solving a little, you know, we're going to have great engineers, a lot of young, great minds. Some of them are in the back of the room, by the way. And they're going to come up with things, you know, over time that we may not even know about now. So it's not a hopeless situation. But if you look at that, the idea is that if we significantly cut emissions, okay, and let's say get greener around the world, well, what's going to happen is the rate of warming will slow, but there's still going to be additional warming, okay? But that's the first thing we have to do, is try to slow the rate of the warming. That's kind of the first step, all right? So that's what the feeling is based on now. Now, why is this serious? Well, because it tends to lead to more episodes of extreme weather. And those, again, are the most dangerous, the most costly in terms of property and sometimes in human lives. So here's the idea of when I talk about, what are we talking about when we talk about changing in the future? Well, if you look as this keeps repeating from left to right, the idea is that the blue is the extreme cold and the warm colors are the extreme heat. So over time, not that it will disappear, but again, you're going to be colder than average much less frequently and warmer than average more frequently. That's what seems to be happening. So here's an example of records that have been set. Cold temperature records are the blue or purple color, and the warm temperature records are the orange color. So you can see that there was a period in the 1960s and 70s where the purple was a little higher than the orange. We actually had more record low temperatures than record high temperatures. But look at the last 4 decades. Okay, the warmer temperatures are beating the record cold temperatures. Record high temperatures are happening more frequently, record low temperatures less frequently, and each decade the disparity is growing larger. Okay, that's what we call pretty suggestive. All right, now we're actually seeing some changes. Because remember when I talked about why we have weather in the first place? Because of the way the Earth revolves around the sun, and it sets up different temperatures and boundaries and storms and all that kind of stuff. Well, there are so many weather patterns that come off of that that we're aware of, and some of them repeat every so often and so on. But the idea is because the biggest amount of warming so far is occurring in the polar regions, all right? And especially in the winter, that's having an effect on the jet stream, which is the band of strong winds around 20, 30, 40,000 feet up. It separates the cold from the warm and tends to steer the storms down on the ground, okay? And we're seeing some differences. So even that winter of 2014-15, the snowiest winter on record in Boston, you say, well, that's still only a decade ago, and we already were warming on average, so why would we have our biggest snow season then, okay? It has to do with the buckling and bending of the jet stream, with the warming in the Arctic, and some of these disruptions, we call them polar vortexes. You've heard names over the last 5 to 10 years in the media, and you go, wow, new discovery. No, not a new discovery. It's just that the media heard the term and went, ooh, catchy, okay? In the meteorological world, the polar vortex has been around for eons, forever and ever, okay? But the point is that it gets stretched and distorted into odd configurations that can lead to weather extremes. And one of the extremes, while we're still cold enough, can be strong nor'easters. And if they occur in the winter and we're cold enough, that's the idea. So the interesting thing is we actually went through a period. We look at 30-year running averages. So, for example, before we got to 2020, whenever we'd be talking about temperatures on a given day or whatever, how was that compared to the average? We're looking like to 1980 to 2010. Then once we get to 2020, we look at the 30-year period, jumping it up 10 years, 1990 to 2000. So when we went from 1980 to 2010 and jumped it up to 1990 to 2020, no surprise, we saw a warming in Boston. So then we looked at the snowfall, and you figured probably went down because it got warmer. No, it went up. No capiche. I'm not even Italian. But what does that mean? How can you have both at the same time? Because of some of the changes can affect the regional patterns. And so we can get the setup for major snowstorms. Now, looking out into the future, there may come a point in time, if things don't change, where some of the major snowstorms in the winter will be major rainstorms because it just gets a little too warm. But we still have it. Although the last few winters, I think it's 3 of them now, we have not had major snowstorms. Are you okay? Okay. All right. So, okay. All right, so that's the idea behind that. So this is a look at this is called the Beer Glacier. We're seeing this in a lot of places. That's 2012, 2019. Look at how much melting. We're talking about, melting the polar ice caps, Greenland. No jokes coming because I said I'm not getting political, okay? But ice melting in Greenland is a real thing, okay? So we're seeing that, those obvious things. And even though we've talked about our average temperatures going up more by night than by day, but happening in both, the reality is it's the oceans where the biggest change is occurring, because 93% of this excess heat is going into the oceans. And so everywhere that you see ocean there, those warm yellow and orange colors are showing a warming in the ocean water temperature. And that can make storms, when you get them, hurricanes more intense, nor'easters or coastal storms for us can be more intense, okay? So when people say, why should we really worry about this? Isn't this like small potatoes? And I go, not really, because I look at it this way. We know that sea level has been rising, slowly but surely. Well, think about it. Even if storms of the future would be the same as the storms of the past, you're going to get a little bit more coastal flooding and beach erosion because sea level is higher to begin with. Now let's add the second compounding effect. Because of the warmer oceans, some of these coastal storms, nor'easters, tropical storms, and hurricanes might become a little bit stronger than they used to be or than otherwise would be the case. So now you have a sea level that's already higher and slowly rising, and a storm that's stronger. So that's a compounding effect to lead to more serious coastal flooding and beach erosion. Then we look at the number of people living near or along the shoreline. That's been going up. I read recently something like 50 to 55% of the population of the United States lives within 50 miles of the ocean. Isn't that amazing when you consider the vastness of the interior land of the United States? But it's always been considered a desirable way of life to be near on the ocean if you can. But that's putting more people in harm's way. And the number of structures that have been built along the coast way up in recent decades. So you have sea level rising, potential for some of the strongest storms to be even stronger than they used to be, more structures and more people in the way. Yeah, I think that adds up to some concern. So that's the idea behind that. And this is showing you the sea level rise by century. And you see a little bit up, a little bit down, a little bit up, a little bit down. Uh-oh. Most recent century, whoops, going up. Now that's a matter of 6 inches. It's not like 6 feet or something. But the idea is it seems to be more of a steady rise that's going on now. All right, so the idea is if the tides are even higher, you're going to get more coastal flooding. So the thing about when you see graphs like this, remember, the general circulation of the atmosphere that drives our weather is complex to begin with. You're going to get many different patterns, many ups and downs. But it's that white line that's going from left to right that's on an angle that's going up. That's the average. So the point is the average number of days where we're getting coastal flooding in the U.S. is going up. All right? And there's actually an equation for this. For every 1 degree Fahrenheit that the average temperature increases in the atmosphere, 4% more water vapor available. Okay? And water vapor is moisture in the gaseous state. All right? That eventually leads to clouds. When enough moisture in the clouds gets released as rain or snow. So a warmer world is a wetter world by definition. More extreme precipitation events. And this is showing what happened from just 1958 to 2016. This is an increase, the percentage increase in heavy precipitation events. Every part of the country is getting a larger number of heavy precipitation events than they used to. But look where the increase is greatest, in the Northeast. Okay? So we are definitely involved in all that. This is showing you Houston, and this is the amount of rain on the wettest day of each year. Again, plenty of ups and downs, but the idea is the average is going up. By the way, that one spike up, that goes way up, that was Tropical Storm Harvey a number of years ago, okay? I know why you're laughing. Not because of the horrendous 40 inches of rain that fell down there. So by the way, this occurred in August, and of course, I wasn't retired yet, I was still working. And so the crazy thing is, there were some emails that were coming into the station while this was going on, because I wasn't there. Not retired, I just wasn't there. There were emails like criticizing the management. Are you afraid to put Harvey on the air because you think we're going to associate him with this horrible storm? But I also received some emails. Hey, what's the matter, chicken? Afraid to show your face? This really happened. Of course, neither of those two things were true. I happened to be on vacation. Now, God forbid that was a local story, I would have been pulled back from vacation. But that's the story with that. So that's what we know about hurricanes and climate change. Warmer ocean water, more fuel for the storms. And that's going to lead into all 3 of the effects of these tropical storms. Heavier rain, a higher storm surge, stronger winds. Okay? All 3. Now this is looking at the Western U.S. Drought Index. Because, we always, we see a lot about the fires out west now. Okay? And it seems like the fire season out there is getting longer, it's starting earlier, it's lasting later. We all know the horrendous, situation that occurred and the tragedies near the Los Angeles area. But the black line, okay, the farther down it goes from top to bottom, that's worse for the drought index out west, and that leads to worse fire seasons. So the same thing here. Lots of variability. This is hotter years, means higher fire risk. But the idea is it's the white line going from left to right, but it is going up on average. So that's why there's concern with that as well. So that's why it's serious, okay? rising sea level, more extreme storms. So we've talked about that. We haven't talked about health or anything like that, so we're going to touch upon that briefly. Some of the impacts, okay, from all the extremes, from heavy rain events, heavy snow events, the flooding, the droughts, the fires, the hurricanes, and so on. This is showing you the number of billion-dollar disasters. That's going up. Part of that is inflation, of course, but even when you account for that, it's going up. And then the animals and the ecosystems, okay? So you will see that. Like, you know, we see in the news now, not just in the summer, really, even before the summer, into the fall, the great whites off the coast of Cape Cod, okay? Many more of them than there used to be. Well, one of the food sources are seals, and the seals are winding up at farther northern latitudes because the ocean water temperature is getting warmer. So it has so many domino effects, all right, to both, you know, the human world, the animal kingdom, and so on. And I remember talking a couple of years ago, before it even happened, I said one of the dangers as we warm is some of the tropical-borne diseases, such as malaria, may sneak into slightly higher latitudes. And sure enough, I think it was the summer before last, we had some cases of malaria in Florida and in Texas, sneaking up a little farther north, okay? All due to the warming. So that's the idea. Now, air quality. If we have hotter days or heat waves or longer heat waves, that's going to be tough because there's always this photochemical reaction between sunlight, especially with warm, hot sun, and automobile exhaust. That produces low-level ozone, which is an irritant to our lungs. And so the hotter it is, the more hot days, heat waves, humidity, and you know, we know it can always get humid at times in the summer. That seems to be getting worse. The stretches are longer and things like that. So all of that can affect, you know, it's difficult. It's difficult for those of us who are older, those of us who are very young, those of us who have health issues, things like that. So air quality is a big thing, and more heat-related illnesses can occur. And okay, so for people who can and like to garden, on average, a longer growing season, because we're finding the average first frost or freeze is happening a little bit later in the fall, on average. And the last frost or freeze is happening earlier in the spring, on average. Again, it's not going to work every single year, but more often than not, it probably will work out that way. So that's pretty good. But those of us who have significant allergies, it's now a longer allergy season, starting a little sooner and lasting a little bit later. So those are just some of the things. And of course, we're humans, but you know, as I mentioned, the animal kingdom and cattle, they're affected by the stress of weather extremes like droughts and floods. And the shifting weather patterns can also mean shifting planting zones, okay? And the risk of increased crop diseases and pests with the extreme heat and humidity, especially in the summer. So sports, skiing, okay? I mean, thankfully, most ski areas have the ability to make snow now because you can't count on the natural stuff from season to season or even within the season. So again, for just one moment, I'm going to mention this for those who are closer to the front of the room. If you think back to your younger years, all right, we used to talk about old-fashioned New England winters. What did that mean? It would mean it starts to get consistently cold, you know, maybe toward Thanksgiving, and you know it's going to be pretty consistently cold into March. Maybe we'll get our first snow late in November, and you could have some snow and ice on the ground, near the curbs, all that, into March. We don't have that very much anymore. Decades ago, I used to talk on the air about the January thaw. What was that? Didn't fully understand it, but it seemed most winters around the second, third week of January, we'd get a bit of a thaw. Could last a few days, could last a week. But calling that the January thaw back then implied it was pretty consistently cold before and pretty consistently cold after for a while. But now, this winter was not a good example, but many of the winters more recently, we don't get the January thaw. We can get multiple January thaws, or even winter thaws, okay? So it seems that it's getting more difficult to have truly long, continuous New England winters. I'm not saying that will never happen, but I'm just saying that, again, the odds are less frequently for that in the future than what occurred in the past. All right, so the idea of solvable or some mitigation, again, the way we're going now is not good. The planet's warming at a slow but steady clip. We want to cut the emissions and slow the rate of warming. That's the first step if we can accomplish that. And then all the other steps that would follow, all the great minds in the back will be solving it over time, okay? That would be the idea going forward. So the greenhouse gas sources are numerous. There are many, you know, that contribute. Okay, so what about clean renewable sources of energy, like solar? Now you might say, oh, gee, is it sunny enough here for it to be a benefit? Yes, it actually is. All over the country, it's a benefit. The greatest bang for the buck, probably in the Southwest, where you have the greatest amount of sunshine. But even up here, may not cover all the needs, but sometimes solar can help with the heating of hot water, so to speak. You know, it may cover part of the needs, all right, here. Wind, we know we can get some pretty extreme winds here, but the average winds are pretty significant here. So windmills and so on, you know, and there are some around, that certainly helps. And okay, I mentioned this in my example earlier with my little experience on the electrical school buses in Beverly. So, you know, we have that going on. And finally, I wanted to mention, and we're getting near the end here. Okay, I don't know how many of you, both younger or somewhat older, have been, let's say, to the seaport, all right? Well, those of you in the back, if you've been to the seaport area of Boston, it's very built up now. But 10, 15 years ago, it wasn't that way, all right? Now, the interesting thing is all of this building, that's considered a flood-prone area. And yet we've had a lot of new construction. So why? Or it's because it's financially, you know, going to work for some people. But here's some of the things that can be done when I talk about mitigating. If it's a new structure, the foundation is going to be built higher off the ground, okay? So that if you get some flooding, hopefully it doesn't get up to the level, the living level, okay? Also, if it has a furnace in terms of, you know, a heating system, not going to be in the basement, going to be at a higher floor. So if you take on water, you don't lose that, okay? So there are ways. I'm not an architect, I'm not a design engineer, but there are things called dynamic glass and insulation and all different things that to have a more efficient use of our energy and to try to diminish the carbon footprint. So there are things, you know, that are going on, and as I said, there'll be many more. All right, so that was really, because I think it's probably close to time. You might have, if we have time for some comments or questions, I'm happy to take them. You have to tell me how we're doing on time. Because I can be, talk to the producers at Channel 5. I can be long-winded, okay? Anyway, but, so.
First, thank you so much to Harvey Leonard.
Oh, thank you.
Wow,
Thank you.
Amazing.
Thank you for indulging me, seriously, and thank you for such a wonderful turnout of all ages, which I love. I just have to tell you, so I gave a talk not too long ago at a senior center in Linfield, and somebody came up to me afterwards and said, oh, Harvey, my grandson wanted to come in the worst way. And I said, oh, how come he or she couldn't? They wouldn't let him. What? Only seniors. I said, you got to be kidding me. But that could have been also for space, you know, to whatever. But in any event, so I really appreciate all of you being here, you know, very, very much. So if there are any comments or questions, but I'm also hanging around, so I'm not leaving immediately. So you'll be able to corral me.
Let us take just a few questions, because I know the Elder Service our lunch crew would like to start serving, but Steve, I'll let you ask a question.
I was interested in the weather since the 60s, but when you, I read about you, when you predicted the blizzard of 78, you were afraid it wasn't going to come into fruition, you know, before it really ramped up.
Yeah.
And all the other meteorologists had it wrong, so they should have been fired, and you should have kept your job.
Oh, wow, that's very kind. And no, I appreciate that. But actually, this also, I want all of you to listen to this very briefly about this, okay? Okay, so it's not like I called every storm correct my entire career, okay? Obviously not. But the whole idea of the blizzard of 78, why would I have done so well and maybe others not? Believe it or not, came down to my education, came down to my graduate school work in meteorology at NYU in the School of Engineering and Science. We had a professor there. His name was Vinnie Cardone, Dr. Vinnie Cardone. He was like amazing. He was basically a meteorologist, an oceanographer, a physicist, and a mathematician, all wrapped into one. But he was very human and very approachable. And I went up to him once because all the classes were so theoretical, and I knew I wanted a forecast, which we call the practical side of the field. I said, Vinnie, you could call him Vinnie. I said, you know, why is there not one forecasting class? I wish you were teaching it. It would be so awesome. He said, I'd love to teach it. I go, well, how do I make that happen? He says, why don't you start a petition? So I started a petition amongst my fellow graduate students. I got 9 signatures. That was enough. He taught the course. I probably learned more about weather forecasting in that one class than all the others combined. And this is going back 50 years, remember. And he was able to be teaching a little ahead of his time that it's what's happening above the jet stream winds, the jet stream level 20, 30, 40,000 feet up. When you have disturbances or cold pockets of air coming from the Great Lakes toward the Middle Atlantic, you're going to get a storm to form. But back then, most meteorologists would never forecast a storm that doesn't even exist yet. Now it's pretty commonplace. But I had the confidence that it was the classic setup. And so really it's Dr. Vinnie Cardone, and he would have been my educational mentor, okay? I just want to briefly tell you I had one other mentor for people, and I'm going to say names that a lot of you in the front are going to remember. Wonderful names. Dick Albert, Bruce Schwegler, Barry Burbank, right? Okay? Those 3 and myself, we had our predecessors to thank. Who am I talking about? You'll know in the front. Don Kent, Bob Copeland. Why? Because even when meteorology was in its infancy, okay, they set up a professional way of weathercasting on television in Boston. And they paved the way for the people I just mentioned, Dick, Bruce, Barry, myself, to follow. So I really have them to thank. The other mentor, there was one person on TV in New York. His name was Tex Antoine, okay? Now, this goes back in the late 50s and 60s. We didn't have computer graphics. We didn't even have magic well, yes, he had an easel and a few cardboards, one of New York, one of the United States. He was also incredibly artistic. He would do the weather. In the middle, he would do the commercial himself, and he could turn a smiling face of a lady into a cup of Savarin coffee, or the other way around, okay? He could do either one. He also started with sayings every night. Listen to this. I'm in middle school. We called it junior high school. And I'm walking 19 blocks home on the Wednesday before Thanksgiving. It's overcast, a leaden gray overcast. It's cold. It feels like snow. It looks like snow. It doesn't snow. So, of course, I'm frustrated because I love snow. So I turn him on, Tex Antoine, 6:15 in the evening, and he starts with a saying. And I remember it word for word even now. He said, I must admit the feeling of snow was in the air, but you'll have to admit snow for Thanksgiving is kind of rare. And I went, oh my gosh, he's talking to me. He's like, there's no other, it's just one-on-one. So for somebody on the air to be able to make a one-on-one connection with a viewer is very powerful. So he was probably the most talented weather communicator I ever saw. So if I'd say that there was a mentor on that side of the things, it would be Tex Antoine. Academically, Dr. Vinnie Cardone. So I was lucky that I did have mentors. Okay, sorry for the long answer.
Excellent. Great question, Mr.
All right. By the way, that's another definition of being old. Whenever I'm asked a question, I go, oh, that reminds me of a story. Because by now, you have your life's experiences to draw upon. So that's how that works.